So we're gonna collect data to graph graphs of certain sounds for our A math project. Hooray!
Okay, so what we're gonna do is we're going to first turn on the tuner, and then afterwards we click this button in order to project a sound of different notes, right?
Is this a tuner?
Yes, this is the tuner.
Okay.
It says it right there.
Yeah, so the different notes we can project ranges from
Low A to high C.
yeah.
The range being that of 4 octaves.
Yeah, okay.
Okay.
So for example, now we're going to measure the number of periods and the number of and the volume of volume that note 4F being projected by the tuner. So now we have the decibel meter, which the decibel meter will be recording the number of decibels the note is being projected from the tuner. So for example, for over here we have the note being projected at an average around 66 decibels, and now it's around 70 or so decibels. So we'll take it at 70 decibels for now. And then
Okay.
afterwards we'll use the oscilloscope, and we're going to pause this, and Evan will be counting the number of repeated cycles that is found on the screen. But because since we're in the school, there's going to be lots of other noises,
Background noises.
background noises which can interrupt the display which can interrupt the reading on the oscilloscope, and this will actually affect our results. So just for this demonstration, we'll be doing it in the school environment and not at home first.
Okay.
So how many cycles is there, Evan?
2.
Okay, that's 2 cycles. Okay. So from this data alone, right, we know that from this data alone we know that a normal sine equation is usually a sine bracket b plus x, bx, and then a will be representing the decibels, so it's 70 units sine 2x. This 2 comes from the number of cycles. Since there are 2 cycles in every period, we can actually put it before the x, and that will actually
Transform the graph.
transform the graph in such that in every 2 pi or 360 degrees there will be a repeater of 2 cycles. Yeah. Other than that, Evan, would you like to plot the graph?
So now we are plotting the graph. Oh my. This is the equation of y equals to 70 sine 2x. The sound produced by the note 4F, as recorded earlier.
Approximately, of course.
Approximately. So these are the final results that we have come at, 2 different graphs of 2 different sounds produced, and it will be subject to further testing based on a standard reference to determine whether it is truly a pleasant or unpleasant sound when the 2 notes are mixed together. But as you can see, this graph over here, the one my finger is tracing, it's very incoherent with the other graphs. So our rough idea would be that it is an unpleasant sound until we can truly test its
We assume that
Yeah.
it's an unpleasant sound.
we
So-
assume that it's an unpleasant sound until we can
Test it
determine and clarify whether it is an unpleasant or pleasant sound, which would disprove or prove our hypothesis.